So this is another one with two cars approaching each other. They're headed towards the same intersection, right? So let's say the intersection's here. One car is going east, so it has to be coming from this direction like this. Cool. And one car is going south, so it's really coming from the north because it's headed south. All right? Yeah, so I'm just tricking you. And they're giving you their rates of change. So like this, and we want to know how fast the distance between them. Yeah. At what rate are they approaching each other? So they're asking for the rate of change of the distance between them, which is this. And that makes that right triangle right there. Okay, so as the cars approach each other, all three of these things are changing. This distance is changing, this distance is changing, and this distance is changing. They're telling me that the car going east is doing 90 kilometers an hour. That's dx dt. They're also telling me the car headed south is doing 60. That's dy dt. So I know dx dt and dy dt, and they want to know how fast the distance between them is changing, so that is dz dt. That's what we're looking for. Cool. And they also happen to tell us that the first car is 0.2 kilometers away and the second is 0.15. So we're going to need those after we do the derivative and start plugging stuff in. Okay? So we need to link x and y to z, and that's just the Pythagorean theorem. Notice we're not doing any kind of trig in a question like this because we don't talk about the angle at all, right? There's no angle rate of change for us to talk about, so we use Pythagorean theorem instead of trig. And then we're just going to derive it. And we've done this before. When you derive this, you get 2x dx dt plus 2y dy dt equals 2z dz dt. And we know all this stuff, except we don't know z, I don't think. All right? But we know x, which is 0.2 kilometers. So it's 0.2 times dx dt, which was really, oh, you know what, I messed up. It's not 90, it's negative 90, right? Because it's getting smaller. So 60 should be negative as well. Okay. Plus 2 times y, what was y? 0.15? Point what? Yeah. Okay. Thank you. Times dy dt, which is negative 60. And that equals 2. We don't know what z is, and we're trying to find dz dt. So again, anytime you miss something, you got to go back up to your picture or the problem and see if you can figure it out. But we know that if x is 0.2 and y is 0.5, that's a 3, 4, 5 triangle, really. Because 0.15 is 3 times 0.05, and 0.2 is 4 times 0.05. So z has to be 5 times 0.05. 0.25. No. It's 0.2 kilometers from the intersection. What's up, Nomi? Because they're getting smaller. Because they're headed towards the intersection. Okay? Cool. So, yeah, when they start talking about rates of change, they're not going to say negative. They're going to say it's changing this fast. You got to think, is it getting smaller or bigger? Okay? What's wrong? Okay. So 0.2 times negative 90 is, you can multiply this out, but that's going to be negative 18. And then times another 2 is negative 36. Plus 60 times 0.15, what is that? 90? 9. 9. 9. So it's negative 18. Equals 2 times 0.25 is 0.5 dz dt. Okay? Cool. So it's negative 54 divided by a half, which is negative 108. Oh, and the units on that have to be kilometers an hour. Per second? No, an hour, right? Cool.